Hi everybody, Bert Zimmerman here again. This is episode 5 for the Racetrack and holding tutorial. In this episode I'm gonna show you how you use the template, that is, how you apply it in some different situations. One being holding overhead a facility, a VOR or an NDB, and the other situation being holding at an intersection fix of two VOR radials or two NDB bearings. First, we need to draw the overhead tolerance for an NDB or a VOR. That will result in the 4 points A1, A2, A3 and A4. Then we take the template point A and place it on A1 and draw the outline. Then we take the template point A and place it on A2 and do the same. Then we place it on A3 and draw the outline, and then we place it on A4 and draw the outline. In the end, we connect the 4 outlines with straight tangent lines. This combines to the basic area that protects aircraft turning in the holding. In order to protect the entries, we need to take the template and use point E as a reference. Now we take the template aligned with the inbound axis of the procedure and use point E and place it on a series of points on the cone of silence from the northern quadrant down to the point where the 70-degree line intersects the cone of silence. This creates an additional protected area indicated with a cyan curve. Also, you can see when flying the entries parallel outbound and direct in the most adverse cases with the YE and XE problem, the aircraft will be protected. When the entry procedure is flown along the 70-degree separation line between the entry sectors, the aircraft heading will determine which entry is flown. If it is a sector 3 heading, then the direct entry is flown. If it is a sector 1 heading, then the parallel outbound is flown. When an entry is flown along the 70-degree separation line between the entry sectors, we need to rotate the overhead tolerance area of the VOR or NDB by 70 degrees to align it with the separation line. This will result in the points E1, E2, E3 and E4. Now you can also see the extreme cases, and that is flying a direct entry from E1 and a parallel outbound from E3. In order to protect the entry procedures, we take the template as shown. We only need the red spiral curve. We must rotate the template counterclockwise by 70 degrees to align the inbound axis with the 70-degree separation line. To protect the extreme cases of the direct entry, we take the rotated template and apply point A on E1 and E3. That produces the two outbound turn spirals, and now, if not before, you should understand why in the first place we created a spiral around the H, O and P points which protected a turn of more than 180 degrees. There is an arc that must be created centered on the nominal facility that is tangent to the spiral at E1 and tangent to the basic area. This will account for any case of flying the direct entry between 0 degrees, meaning aligned with the inbound axis of the holding, and the 70-degree line. To protect the parallel outbound entry flown that way, we need left turns. If you created your original template on a transparent paper, you can just flip it over. If you do your construction on a computer-aided design program, then you can just use the mirror command. So we take the rotated and flipped over template aligned with the 70-degree axis and place point A on E1 and E3 again. That results in the protection extension, which is shown in green. To protect the procedure at an intersection fix, we create the fix by using the tracking aid shown in blue here and the intersecting aid shown in amber color here. The fix area is made up by the points A1, A2, A3 and A4. To create the basic area, we take the template aligned with the inbound axis of the procedure and place point A on A1, draw the outline of the template, A on A2, draw the outline, A on A3, draw the outline, and A on A4 and draw the outline. The combination of the four outlines of the template produces the basic area that protects traffic holding in the pattern. Here we cannot enter in an omnidirectional fashion. The only possibilities to enter the pattern is along the two radials that actually form the holding fix. Depending on the angle that forms the intersection, that will only result in a subset of possibilities to enter the pattern. In this example, the two yellow aircraft will have to do a direct entry. The green aircraft will do a parallel outbound entry and the blue aircraft will do an offset or, depending on the heading, also a parallel outbound. When you enter along the radial that forms the inbound axis of the procedure but on the reciprocal track of the inbound course, we again need to cover for the XE and YE problems. To account for that, we take template point E again, aligned with the inbound axis of the procedure, and place it on A2 and A4. That creates an additional curve beyond the basic area. If you enter along the intersecting radial, the roles of the two radials will invert. That is, now the intersecting radial becomes the tracking radial, and vice versa. PANSOPS foresees to construct fixed tolerance areas for both cases. That means you have one fix created with the blue radial as the tracking and the amber radial as the intersecting, and one doing the opposite. If you want, you could be pragmatic here and generally construct the intersecting fix area based on two tracking tolerances. It's going to be a little bit more conservative than necessary, but it saves you some hassle. If the intersecting facility is in Sector 2 or in the part of Sector 3 opposite Sector 2, the yellow aircraft will fly an offset entry and the green aircraft a direct. Such direct entry needs some additional protection. So we take template point A again, align the template with the entry radial and draw the red curve from E3 and E4. This results in the additional protected area indicated in cyan color. A special case occurs when the intersecting radial is exactly aligned with the 70-degree separation line of the sectors. In this case, if you enter top to bottom here along the 70-degree intersecting radial, you can expect both a direct and a parallel outbound, and hence you need to protect for both cases. If you want to exclude entries to reduce the protected airspace, you can do that, but it needs to be coordinated with ATC. If you do exclude entries, that means ATC cannot clear aircraft direct to the holding fix and let them enter. Okay, that was, for the moment, I believe, the last episode. Maybe we will continue with this at some point using VOR DME holdings and explain the application of the template to that. But for the moment, I believe this should do for holdings and racetrack, and I hope it was more or less understandable and you can make use of it. So thanks for watching, stay tuned, stay healthy, see you next time. Bye bye.